Welcome to a variation of parameters example. So recall, if we have p0 of x times the nth derivative of y plus all the way down to pn of x times y equals f of x, has homogeneous general solution yc is c1 y1 plus all the way through cn yn. Then the equation for the non-homogeneous equation has solution y equals u1 y1 plus all the way through un yn, where uj prime is -1 to the n plus j times f of x divided by p0 of x times wj over w, where w is the Wronskian, and wj is a subdeterminant. So for example, let's go ahead and solve the equation, third derivative of y minus 3 times the second derivative minus y prime plus 3y is equal to e to the 2t times t minus 1, using this variation of parameters technique. So the first thing we need to do is find the homogeneous solution. So we have characteristic equation. R cubed minus 3r squared minus r plus 3 equal to 0. This we can run factor by grouping. The first group we would factor in r squared. The last group we would factor in r minus or -1, and what would be left would be r minus 3 from each of those groups. So we have r squared minus 1 times r minus 3, or in other words, r plus 1 times r minus 1 times r minus 3 is equal to 0. We wind up with r is -1, 1, or 3. So we get general homogeneous solution yc is equal to c1 e to the -x plus c2 e to the x plus c3 e to the 3x. Going from here, now we'll go ahead and run variation of parameters. So running variation of parameters, we're going to assume that y is equal to u1 e to the -x plus u2 e to the x plus u3 e to the 3x. And we get then that uj prime is equal to We have -1 to the n plus j. So in this case, n is 3. -1 to the 3 plus j times f of the x over p naught. So for this problem, our f of x is e to the 2t times t minus 1. Oh. These should all be t's, not x's. Our p0 of x is just 1. I'm going to just quickly change all of these to t's instead of x's. So we have c1 e to the negative t, c2 e to the t, plus c3 e to the 3t. We're assuming y is u1 e to the negative t, plus u2 e to the t, plus u3 e to the 3t. Again, our uj prime, we have -1 to the m plus j, in this case 3 plus j, times e to the 2t times t minus 1, that was the right-hand side of the equation, divided by 1, that was the coefficient of our nth derivative. Then we're going to multiply it by our wj over w, our Wronskian. So what we want to do here is just find all of those components. So we are looking at the matrix. So W is the determinant of our matrix Y1, which is e to the negative t, Y2, e to the t, Y3, e to the 3t as our first row. And then we take the derivatives going down. So we have negative e to the negative t, e to the t, and 3e to the 3t as our second row. Taking derivatives one more time, we would have e to the negative t, e to the t, and 9e to the 3t as our last row. Our subdeterminants, W1, we are eliminating the last row and first column. So we're just looking at the matrix e to the t, e to the 3t, e to the t, 3e to the 3t. Again, that's just eliminating the last row and the jth column, or in this case, the first column. Our W2, we're eliminating the second column. So we'd have e to the negative t, negative e to the negative t, and then e to the 3t, 3e to the 3t as our two columns. W3, we're taking the determinant of the submatrix where we eliminate the third column and the last row. So we're just looking at e to the negative t and negative e to the negative t for our first column, and e to the t, e to the t for our second column. So I personally recommend calculating the subdeterminants first, because we can use those to calculate our final determinant. So W1, we're just looking at e to the t times 3e to the 3t minus e to the t times e to the 3t, or 3e to the 4t minus e to the 4t gives us 2e to the 4t. The next subdeterminant, again, we have e to the negative t times 3e to the 3t. And we are subtracting off a negative e to the negative t times e to the 3t. So we are looking at 3e to the 2t plus e to the 2t, and we get 4e to the 2t. For our last subdeterminant, we are looking at e to the negative t times e to the t, and we are subtracting off negative e to the negative t times e to the t. That's just 1 plus 1, otherwise known as 2. Our Wronskian should just be that first subdeterminant. We eliminated the third row and first column. So we would do -1 to the 3 plus 1 times W1 plus -1 to the 3 plus 2 times W2 plus -1 to the 3 plus 3 times W3 is how we could go about finding that. Again, each of these we're just looking at n plus j as our exponent, and our subscript here is j. So putting these all together, we have that our W, which was -1 to the 4th times W1 plus -1 to the 5th times W2 plus -1 to the 6th times W3. W1 was 2e to the 4t. So we are looking at -1 to the 4th is +1 times 2e to the 4t. Oh, sorry, I forgot. We also should have what is in that spot. So we would have W1 times e to the -t, W2 times e to the t, and W3 times 9e to the 3t in our formulas, right? When we do the determinant, it's -1 to the n plus j times whatever's in that nth row jth column spot times the submatrix we're working with. So I apologize for that. So we should have a e to the -t, e to the t, and 9e to the 3t again in this formula as well. So we have, this becomes 2e to the 4t times e to the -t for that first term. -1 to the 5th is negative, so we're subtracting off 4e to the 2t times e to the t. -1 to the 6th, we're now adding on 2 for W3 times 9e to the 3t. This is 2e to the 3t minus 4e to the 3t plus 18e to the 3t. And so we get that our Wronskian is 16e to the 3t. We now know all the information that we need for solving for our uj primes. So we have that u1 prime is -1 to the 3 plus 1 times e to the 3t times, sorry, e to the 2t times 2 minus 1. Divided by 1 times our W1 was 2e to the 4t. And then we are going to divide by our W of 16e to the 3t. Our U2 prime, actually, let's go ahead and simplify that. -1 to the 4th is 1. E to the 2t times e to the 4t is e to the 6t divided by e to the 3t, which is e to the 3t. So we will have 1/8 e to the 3t times t minus 1. Our U2 prime, we will have -1 to the 4 plus 1. Sorry, to the 3 plus 2 is how I should write that. I apologize. Times e to the 2t times t minus 1 divided by 1 times our W2 was 4e to the 2t. Then divided by 16e to the 3t. We'll have that is negative e to the 2t times e to the 2t is e to the 4t divided by e to the 3t is just e to the t. We will have a negative 1/4 e to the t times t minus 1. Our u3 prime, we would have negative 1 raised to the 3 plus 3 times e to the 2t times t minus 1 divided by 1. Then we are multiplying by our u3, or our w3 was just 2. So we multiply by 2 over 16 e to the 3t. This is a positive. We would have 1/8 e to the negative t times t minus 1. So at this point, all that we're left with is we need to integrate to find u1, u2, and u3. So we need to integrate to find u1, u2, and u3. Note that all of these have an e to the alpha t times t minus 1. So I'm going to actually just integrate first. I'll involve an e to the alpha t, or an integral of e to the alpha t times t minus 1 dt. So I'm going to integrate that just generally first, and then we'll go from there. So if we take our u to be t minus 1, our dv to be e to the alpha t, we get 1 and 0 as our derivatives. We have 1 over alpha e to the alpha t, 1 over alpha squared e to the alpha t for our integrals. And then multiplying on the diagonals, adding the first, subtracting the second, we get that this integral is 1 over alpha times e to the alpha t times t minus 1 minus 1 over alpha squared times e to the alpha t, which of course we could always rewrite if we wished, distributing things out, or we can leave it in this format as is. Let's go ahead and rewrite this as this is 1 over alpha e to the alpha t times t. And then we have minus 1 over alpha plus 1 over alpha squared times e to the alpha t. Or in other words, 1 over alpha e to the alpha t times t minus alpha plus 1 over alpha squared e to the alpha t. And then of course we have our plus c. So we have u1 prime was equal to 1/8 e to the 3t times t minus 1. So we have that u1 should be equal to, we would have 1/8 times, we would have 1 over alpha e to the 3t, so 1 over 3 e to the 3t times t minus 3 plus 1, 4 over 3 squared, 9 e to the 3t. And then plus c1. Or we could just write this as e to the 3t times 1/24 t minus 1/18 all plus c1. our u2 prime was equal to -1/4 e to the t times t minus 1. So we have u2 is -1/4 times, so we have 1 over alpha times e to the alpha t times t. So here alpha is 1, we just have 1 over 1 times e to the t times t, minus we have alpha plus 1, so 1 plus 1 is 2 over 1 squared, 1 times e to the t plus c2, otherwise known as e to the t times -1/4 plus 1, sorry, -1/4 t plus 1/2, all plus c2. For our u3 prime, this was equal to 1/8 e to the -t times t minus 1. So we have 1/8 e to the -t times t minus 1. This gives us that u3 should be equal to 1/8 times, we would have 1, I apologize. So we have u3 is equal to 1/8 times, we would have 1 over alpha, in this case alpha is -1, so 1 over -1 e to the -t times t, minus alpha plus 1 is just -1 plus 1 is 0 over -1 e to the -t, and then all of this plus c3. So we wind up getting that our u3 is e to the -t. Actually, we don't even need to write it in that format. We just get -1/8 e to the -t times t, since the rest is 0, and then plus c3. Putting these all together, so now find y, which was u1 times e to the -t plus u2 e to the t plus u3 e to the 3t. So we have u1 times e to the -t plus u2 e to the t plus u3 times e to the 3t. So we are looking at u1, we just found to be e to the 3t times 1 over 24t minus 1/18 plus c1. So we have e to the -t times e to the 3t times 1/24 t minus 1/18. And then plus c1, that e to the -t is also multiplying the plus c1. Then we have plus e to the t times our u2, we had e to the t times -1/4 t plus 1/2. And then plus c2, that e to the t is also multiplying the plus c2. Then we have plus e to the 3t times -1/8 e to the -t times t plus c3. So we get that y is equal to e to the 2t times 1 over 24 times t minus 1 over 18 plus c1 e to the -t plus e to the 2t times -1/4 t plus 1/2, and then plus c2 e to the t plus we would have e to the 2t times -1/8 t, and then plus c3 e to the 3t. And we can, of course, condense this. This is e to the 2t times we have 1/24 minus 1/4 minus 1/8. That's 1/24 minus 6/24 is negative 5/24. Minus 3/24 would be negative 8/24. And we get negative 1/3 t. Minus 1/18 plus 1/2. We would be looking at negative 1/18 plus 9/18, which is 8/18, or 4/9. So I have e to the 2t times negative 1/3 t plus 4/9 plus c1 e to the negative t plus c2 e to the t plus c3 e to the 3t. So this is our final solution, running variation of parameters. Again, it's completely up to you whether you prefer to run variation of parameters or method of undetermined coefficients if our original equation has constant coefficients. So as a matter of preference, hopefully I did not make an arithmetic error here. If I did, at least the process is set. I'll do one more example in the next video.